Welcome back to our videos on solving radical equations. Now we're going to look at solving radical inequalities. So as a reference, we've looked at solving radical equations and we had this nice four-step process. That four-step process isn't going to go away when we solve radical inequalities, but it is going to become adjusted. So now we're going to look at solving radical inequalities and we're going to step through the process here. We're going to start by looking at a simple inequality here, where I have 3 plus the square root of 5x minus 10 is less than or equal to 8. We need to remember a few things. We need to remember that a less than or equal symbol is going to indicate a closed or shaded circle, whereas a less than would indicate an open circle. Same thing with greater than or equal to will be closed, and just greater than will be open. So when I look at these problems, the first thing I want to look at is the domain. If you're having trouble remembering what the domain of one of these functions should look like or what the domain is, make sure you go back and look at the video on domain of radical inequality or of radical equations. So this is a square root, which means I can't take the square root of a negative number. Anything squared is positive. So my step one here is I need to find the domain. My domain is that I can't put a negative into a square root. So 5x minus 10 must be greater than or equal to 0. It can be 0 and it can be positive, but it can't be anything else. So 5x is greater than or equal to 10, x is greater than or equal to 2. This is my domain. That means that on my number line, I'm going to mark 2, and everything to the left of 2 is no good. X must be greater than 2. If it's less than 2, something's gone wrong and I can't get a solution. My graph doesn't exist. This function doesn't exist. So now I want to look at the next step of solving this. My next step of solving is that I need to make an equation. To make an equation, all you're going to do is take the inequality symbol and turn it into an equals. You'll notice that I marked what type of inequality symbol I have. I'm going to end up with closed circles, and I want to keep track of that, so I marked that up top. But I'm going to start by 3 times the square root of 5, or 3 plus the square root of 5x minus 10 is equal to 8. My next step, once I've made an equation, is I'm going to solve it algebraically. That means I'm going to go through the four-step process from before. So solving algebraically, I have that four-step process. I'm actually not going to go through the check step. I'm just going to keep it at the first 3. So I need to isolate, raise, and solve. All right, isolate. Raise, I'm going to square both sides to get rid of the square root. Remember, if it was a cube root or a fourth root, we'd need to raise it to the appropriate power for that. And now I'm going to solve. And I get x equals 7. This is a critical value. We're going to call this value a critical value. I'm going to mark this critical value on my number line with the correct symbol, which is this closed shaded circle here. Now that I have that closed shaded circle there, I need to go through and check regions. I know this region to the left. I really have 3 regions here, broken up by my domain value and my critical value. Everything to the left here is no good because it doesn't fall in my domain, but I need to check points in each of these regions. So I'm going to check 4 because 4 is between 2 and 7, and I'm going to check 10 because 10 is to the right of 7. So now when I go through and check these values, I'm going to check 4. So I'm going back to my original inequality to do the checking. 3 plus the square root of 5 times 4 is 20 minus 10 is less than or equal to 8. 3 plus the square root of 10 is less than or equal to 8. Now, I don't know what the square root of 10 is off the top of my head. I could pull out my calculator, but if I don't have a calculator at my disposal or I'm not allowed to use my calculator, I need to figure this out somehow. And by the way, we're on step 4 now. This is our factor line analysis. So to figure out what the square root of 10 is, I want to think to myself, what square roots do I know that are near 10? I know the square root of 16 is 4. So this number can't quite be 4. And I know that the square root of 9 is 3, so I know this number is bigger than 3. So this number is going to be 3 point something. 3 plus 3 point something is about 6 point something. 6 point something is less than or equal to 8. So this region is a happy face. It's a success. In this case, this is greater than or equal to 2. So that greater than or equal to is going to get a closed circle, and I'm going to shade in that region there. To check 10, I'm going to go through a similar process. You'll notice I don't actually care what the square root of 10 is. I just cared what it was approximately. That's going to happen again. So I have 3 plus the square root of 10 times 5 is going to be 50, minus 10 is less than or equal to 8. 3 plus the square root of 40 is less than or equal to 8. I run into this same issue again. I don't know the square root of 40. I know the square root of 49 is 7, and the square root of 36 is 6. So this number is going to be somewhere between 6 and 7. 6 point something. Maybe 6.5, maybe 6.4. I'm not quite sure what that value is. 3 plus 6 point something will be 9 point something. That is not true. 9 something is not less than or equal to 8. So this region does not represent my solution set. The only portion that represents my solution set are those values between 2 and 7. Any number between 2 and 7, including 2 and 7, will make a true statement here.